Okay, so the graph looks like this: 1, 2, 1, 2. So we have horizontal asymptotes at two places. At y equals 2 and y equals negative 2. So this illustrates the fact that we could have two horizontal asymptotes. Two Haas, that's right. So we have negative 2 and we have positive 2. And again, if we just inspect numerically what's happening here, root x squared plus 1 approximately equals root x squared for x approaching plus or minus infinity, or that'll just be the absolute value of x. And so when you have 2x, or absolute value of x, that's for positive infinity approaches 2, and for negative infinity approaches negative 2. Okay? Moving right along. If you look at the theorems, same as before. They're really no different. So as x approaches plus or minus infinity, it's still going to be L plus M. So the limit of f of x plus the limit of g of x. Same thing, L minus M. That's times, by the way, sorry. L times M. Km. It's supposed to be times. Sorry. L divided by M. Just Microsoft Word being weird. That's L raised to R over S. So again, we assume that L and M are real numbers. All right. Let's move down to next part. How do you guys think part A is going to look, the graph? Oh, great question. To do this in the calculator. So the question is, how do we do this in the calculator? Do you like that? Yeah, the notation of just saying sine squared x is just make it more compact, but in the calculator, sine x carry to the second sign, or second symbol. The graph will look like this if you're actually to graph it. Because it's always going to be positive, right? And it's never going to get past 1, because the amplitude's 1, and 1 squared is 1. Okay, that was a little too high. That's great. Okay, so anyway. Can we find a limit as x approaches infinity for the first graph, part A? Does it ever stop anywhere? It kind of just goes up and down between 0 and 1. So that's D and E. Because it kind of goes back and forth. Likewise with cosine. Which looks like this. That's also D and E. When you look at the graph. Because again, cosine is alternate between 1 and negative 1, but when you square it, it's actually alternate between 0 and 1. However, sine squared plus cosine squared, this is interesting. If we add these two, well, we know sine squared plus cosine squared is what? 1. So it's interesting you notice that parts A and B are D and E separately, but when we add those two limits together, D and E plus D and E, actually, this will get us a limit. So again, those theorems don't tell us what happens if L and M don't exist. But L plus, if we do add those two functions, we still get a limit. And of course, you plug infinity into a constant function, it's still going to be 1. Not sure what else I want to say about this. I think that's fine for now. Okay. We're going to stop right there because I really don't want to start something new. This is kind of where I want to be at.